Hey everybody, I hope everyone had a great weekend and a Monday so far. Oh, it's been a pretty busy weekend for me, but it's starting to quiet down a bit now. So let's go ahead and get back into programming. Alright, so I decided to work some more on our 2D lights project. This 2D list is pretty empty right now just because I pretty much know everything we need to do until we get this prototype complete. And right, so let's just go ahead and see how far we were. We got, the shadow texture, which is here, this little object. Basically mirrors the shadow mesh you can see over in the editor view here. And when I move the light around, we can see that the shadows update in real time. So both you can see the meshes here and also the texture right here. So everything's working great so far. There are some issues, such as we can see the shadows always have 4 vertices, and sometimes it needs to have more to go around edges. Also, it's not that not very efficient because it actually uses physics raycasts, which turned out to be not the greatest idea. I thought that it might actually be faster than trying to do the math myself, but I guess it still could be, but I expect it's not. And some other issues also is that each of these meshes, it's not like the most intelligent algorithm because it creates a 4 vertice mesh for each side of these platforms, even the ones that overlap. And I suspect that if we wanted to optimize this, we could easily figure out which meshes aren't needed by looking at the clockwise winding. But yeah, I'm going to not worry about all those things for now because I want to get on to actually cutting out the light. So right now we can see, you can't really tell over in this editor view, but in the play view you can see that the light actually shows up behind the platforms, and we actually want the light to be masked out behind the platforms. So basically we'll use a shader to make it so the light is invisible behind the platforms. And that's kind of what this texture is going to be, although some people might have noticed that it's actually inverted right now because the red part is actually the part that of the light that we want to disappear. So for it to be a mask, it should actually be reversed, that the red part will be the part that is shown. And thankfully that's not too difficult. First thing we need to do is go to the camera here and set the background to be white. And then if we just play right now, I think... Okay, that's interesting. I thought that the entire... Oops, I'm moving the camera around, that's not what I meant to do. I thought that the entire texture would be white. I guess this solid color doesn't actually affect it. Okay, let's okay, I had to turn up the alpha. That's a little strange. Okay, so now we can see this is all white. Although it seems like the shader does not work on the back color. Because I was expecting the shader to take care of this and it would turn the white into red. But I guess that's not a big deal, we can just set the color ourselves like that. Another thing is that this shadow is not completely red either. You can see, obviously because the background is completely red and the shadow is actually darker. But that might not be an issue. So actually what we need to do is I'm thinking that well, I guess I won't worry about it for now. it seems, because I want the this mask to only be rendered on the red layer of the texture, or the red channel of the texture, but it seems like the background is not affected by the shader, which means that it's probably, well, obviously it's just writing to all channels. So we'll have to think of something else to take care of that in the future, but for now I'll just leave it kind of lazy. I guess I want red all the way up. And then we need to change the shadows to actually be black, so they will be not shown on the mask. I guess another way to do it, yeah, let's try something else. So I'll leave this just how it was. And we'll go into our render, our shader here, and it will just basically invert everything. So how do I do the fill? Okay, well I guess everything would start out white, so yeah, the camera can go ahead and do that. Because that means it'd basically be shown for all lights. Okay, so this might work out okay. That's interesting. So this area should actually be red or black now. I wonder if this red is like 128 and why that would be. Or like 0.5, I mean. I guess it must be because when you invert the shader, it returns the same value. So what happens if I just return the color? I guess I'll leave this around. Oh yeah, so it's like a weird gray. Why is it doing that? Because I'm pretty sure the material for the shadow should be not caring about the color. Yeah, it's unlit. And the main color is completely white. But obviously it's still gray. Why is that? I just noticed I need to change the name up here. So this should be oops, 2D lights render to red channel. That doesn't help me figure out why. Does it have something? It must have something to do with lights. I obviously don't. I just sampling the texture right here. Oh, well maybe it's because this shader doesn't actually. Oh well, no, it takes the texture from the camera. Okay. So if I change the shadows layer to just the visible layer, it shows up as white. So it has something to do with this camera. Well, now this is completely white. Oh, that's because the camera was on, I guess. Okay, so if I change this to show visible. So yeah, this stuff isn't a weird color. Well, I wonder... It doesn't make much sense to me. See the shader? It's unlit. Okay, so now when I do this, it just is all white. I think. Let's try this. We'll change the shadow cutout material. And then if we play... Okay, so the visualized cutout is not showing anything. So if I change the camera color to black... Okay, so it is pure white. Okay. So I don't know why I guess something's wrong with that cutout, with that color shader, which is a bit of a shame, but this will work fine. And then if we do this, it should just return the red color from this texture. Okay, so now it's all red. Obviously, if we were going to render just to the red, we actually overwrite the other channels. So I'm not sure exactly. We'll just need to figure out how to just set one channel for the color. I'm sure that there's some way you can access what's already in the texture. I'll have to look into that. Okay, but now this is what we want. Oh well, no, it's still backwards, isn't it? Because we want the background to be red. Or white, actually. We basically want this part to be the opposite of red, which is yellow, I think? I forget what it is. Well, I guess we can see right here if we turn red off. Okay, so it's cyan is the opposite of red. So that's what we want to happen. So the way we do that is go back to inverting this. Which, yeah, this shader is definitely not going to be what we'll use. But I just want to basically construct a mask here and we can worry about trying to get it correctly later. Okay, and then I need to set these to 1. And then we should have a nice cyan, which is the absence of red, which means that everywhere that's not cyan will be the parts that will show of the light. Okay. So now we gotta get this light to be masked out with this texture. And there already is like a mask, but I don't think it will work for what we need to do. Oh wow, what happened there? Oh, I changed I need to make a new shader here. So this will be a light mask. And we'll just want to change it to sprites, mask. So isn't there a mask component? I think we tried this already because yeah, it takes a specific sprite. We can't have just a texture. And also, it probably doesn't work with just one channel. So that's why I need to make my own shader. So let's go back to the sprite for now. so let's make a new... Oh yeah, I can't create it from inside here. Right here, so we'll want an unlit shader, and this will be mask from red. And again, I don't want any fog, so I'm just going to delete anything else to do with fog. Okay, so we'll have the actual texture, which will be the white. Then we'll have mask. Let's set this stuff up. Alright, and I need to name it up here. So this will go to 2D lights, mask from red. So right now it's just showing the mesh for the sprite. Yeah, so we actually, we can't use this sprite renderer. We'll need to create another, basically a plane. Can do it, but the thing is it has different UVs, which will make it a little difficult to set up. So we can just do it in code like we did before. So I guess that's what we should do first to make sure this will actually work. So we'll want a mesh filter and a mesh renderer. And then this texture will actually be the light mask render texture. Right, we won't do anything with it yet. Okay, but let's create another component here to actually just create the light mesh. I'll do it in C#. So this will just be light mesh creator, and I can kind of just cut this code. Got this right here, where we just create this mesh. We won't have to do anything else really. Filter. So why don't we go ahead and create float radius. This will just be the size, so that way you won't have to do scale in case that ends up being a little strange. Compiled, we'll have the light mesh creator, and let's just do a radius of 2. And let's see if it works. Oh, this visualizes in the way. It's no. Right now, well, it shows it, but I think it's because we don't take alpha into consideration. so this should be transparent. I think that would work. Yeah, because we just return the color right away, which uses the alpha channel. And we don't do anything with the mask yet. Oh, nope, still doesn't work. Let's just use a simple shader to make sure that everything's set up right. I want it unlit actually. Okay, so it must be something with the UVs, I guess, since this unlit texture is not working right. Unless the unlit texture doesn't have alpha either. Okay, this will be transparent cutout. Okay, this is how it works. Okay, well I was hoping it would let me see the code for that, but it looks like not. Because I wanted to see if I did the right tag there. Basically, if color alpha is less than 0.5, then we can just set it to 0. That shouldn't make any difference though, because the alpha is already 0, but okay, so let's just look here, Unity cutout shader. See the code for it. Okay, so yeah, the render type is transparent cutout. Of course, most of these examples are using the surface shader code, which we actually won't be using. Did I do the code wrong there? Oh, I forgot the semicolon. Oh, we're still using the default cutout. So it's still white. Excuse me. Alright, so still I'm not doing something right. It's transparent cutout. So let's see, Unity unlit cutout shader code. I knew that there was some way you could download it, so we'll just copy some stuff here. So yeah, it doesn't even have this code, it has more stuff about the fog. Really the only difference between ours is of course the fog and then add this code, which this could actually be the issue. I don't know exactly what this does, but I remember it is important for certain shaders. Okay, so now I guess that was the magic number we had to do. Okay, so one other thing I need to do is I need to set the sorting layer so that it will show up behind the lantern. Which I think I can do from here. I'm not sure if it's something I need to handle in my shader though. So render.sort order. Set to -1, it should show behind the lantern. Okay, yeah, now it does. So now we just gotta work with the mask. So one thing I did here is you're kind of, in order to import a variable from the outside world into a shader, you kind of have to do it two ways. First, you have this property, which is kind of like, just tells Unity how it appears in the editor, and then you have to come down here and add it. So this will be mask. And oops, that is well, right. All this stuff just kind of happens magically. It just knows that these variables go to each other. And what this st is, basically the x and y components of this float4 have to do with the offset for texture, and then the z and w components kind of tell like how often this texture will repeat if you set it to tiling. We won't actually use it, but so we need the world position. Which is in this vertex, isn't it? So, yeah, because we need the world position in order to sample the mask texture. So fixed for mask equals text 2D. And we'll take the eye vertex. I'm pretty sure this will work because the mask is the size of the screen. And this vertex is the position of the vertex in screen space. That's what this object, our Unity object to clip position is. It transforms the local vertex position of the model into the world position. And I think this will only take the x and y, which is right. Yeah, x, y. Oh, I said text to be. So, if mask red, we'll just do greater than half, then we'll return color, else return fixed for 0, 0, 0, 0. Basically, since we'll have 0 alpha. So this is actually bad. In shader, you never want to have an if-else statement, I just remembered. So I think the better way to do it is maybe just multiply the color by the mask red. Because if the mask is, if the red is 0, then that would change the color to 0. Another way we could do it is say return fixed for color red, color green, color blue, and then we need to return the mask red as the alpha. Yeah, that way we attain the same result, but we don't have to have an if-else statement. And if-else is just really slow in shaders because the just the way the graphics card works is it tries to like calculate many different lines of code all at once, and if you have an if-else statement, then that means it might have to throw away some code that's already calculated. So this should work okay. Except I don't know. I guess whenever I write in shader code, I get into thinking it's Lua or something, and I leave out the semicolons. Don't need that warning. Okay, so let's see if this works. Okay, so now once I did that, it's gone back to not working well. Oh, because we can't just take the mask R by itself, we also need to multiply it by the actual color alpha. Because if the mask, if the light is invisible in that position, then we'd also still want it to be invisible even if the mask is present in that position. Okay, so now it works normally, and if I move the lantern around, oh no, it did not get masked. Okay, that's a bit of a shame. Okay, so let's try something else. It's hard to debug shaders a lot of times because you can't use like debug logs, and oops, sorry about that. That's the main way I debug in Unity usually. But a cool way to do it is actually like just set values into the actual colors. And now we'll see what the mask value is on these positions, and it should change as we move the sprite around the world. But currently it's white right now. Okay, so we have the mask from red, and it's set up to use the mask that we're constructing. Although I wonder if it's the same one that the camera is rendering to. Well, they both point to this asset, so I would guess so. So what I'm expecting to happen is that when we move, you can, if you watch in the editor screen, when I move the mask over a part that the shadow mesh is covering, the light should not appear there. So basically the light shouldn't appear anywhere below this line on the platform, but obviously we can still see it. And a little strangely, no matter where I move it on the screen, it seems like the light is not being affected. Oh, here. It flickered. I was going to say the light seems to not be actually affected by the mask texture at all. This leads me to think maybe this vertex value is not actually what I'm thinking it is. Like maybe the vertex is 0 to 1 in screen space instead of... Oh, maybe that's the issue. The vertex is probably actually from 0 to 64, but textures are 0 to 1. How would I guess the easiest way would be to divide by 64. That seems really hacky. Let's try it, I guess. So fixed to, so x divided by 640. Oops. So if this works, at least we're on the right track, but obviously we need to come up with something a little cleaner. And it does work. Yeah, you can see the light is being masked by the shadow. It's not perfect because our shadow meshes don't work perfectly. Like obviously when the light's here, the shadow mesh should cover the whole bottom of the screen. But that's just something we need to work on there, but it is being affected. And at certain points it is being completely covered. That's a pretty cool effect actually. Okay, so that was the issue. So we need some way to transform the world space or screen space, which is basically the pixels width and height, to the texture space, which starts here at 0, 0 to 1, 1. And there's got to be an easier way than just using the actual resolution. But I'm not sure what that would be. Basically we need to find the width of the texture. Because in the final game, I mean, another thing also is that there's no reason for the mask to be any bigger than the actual light sprite. So, and we'll have better implementations of this that don't use the entire, that the render texture doesn't have to be the whole size of the screen. So I'm not sure how much time I want to use in getting that little code to work. Still pretty fast actually. So there's 5 batches, and that's just because we have one rendering for the normal sprites, one for this test texture, then one for the shadow meshes, and one for the light. If I turn off some of this stuff, the batches should go down. And the shadows, I turn the system off. Yeah, that the shadow render goes off and then the visualize cut out. I'm not sure why it always says there's 2 batches, because even if I turn this off, it says for some reason there's 2 batches within here, which doesn't make any sense to me because all these sprites should be able to go into one draw call because maybe it's just because they're not Atlas right now. That could be because it's in the editor, so it didn't like combine them all into one texture. Okay, so let's see, what do we need to do now? Basically, I mean, we have a proof of concept, but it needs a lot of work. So first off, we need instead of just having a big to-do, let's separate this. Well, I don't know. We need to have so the 2 big parts of this project that need work is the shadow rendering, or basically the shadow mesh creation, which creates the mask, and then actually applying the mask to the light. And a couple things and I still haven't figured out how to render multiple lights onto the same texture. That's one thing we need. So there's a bunch of smaller projects that we can kind of just pick and choose. So yeah, multiple, say a render multiple lights onto the same mask. That might be a big thing to do because that will require us to figure out how to render one shadow mesh to one channel, and then render shadow mesh to one section of the mask, or let's say of the texture. And that's because, as I said before, the mask can actually just be constrained to the actual size of our light. So if we say our biggest light texture would be, I don't know, 256 by 256, then we can have one big texture that can have several different masks in different quadrants. And each quadrant can hold up to 4 masks because each channel, the red, green, blue, and alpha channels can each contain one mask. So even if we just divided this into 4, we could have 16 different lights. So that's one thing. And then obviously we need to actually test, that's the wrong weather, physics or math based raycasting is faster, and then we need to handle shadow quads with which hit multiple world borders, if I can spell that right. Okay, I just put the I in the wrong spot. And that's this issue, like right here. This hits the right and the top, so it needs to also go all the way to the corner. And then do not create unneeded, shadow quads. Yeah, clockwise winding basically. So like for here, the bottom quad does not need to, actually no, the bottom quad is the one that should be created, but this top quad also is. And it's wholly contained within the bottom quad, except it has a clockwise winding, so it's not even shown. And so we should just not even create that. There's another thing we could do. Like say here, there's 2 quads and or 2 platforms, and this, let's get rid of this. This platform completely covers this platform. So technically we could just not even render the meshes for this, but that of course makes the raycasting a lot more difficult because we have to raycast against every platform instead of just the borders. So I think trying to do that would actually be quite a bit slower. So I don't think we'll do that. But just a note here, maybe look into not creating quads covered by another. Because really, I think having a few extra shadow quads is not going to slow down the rendering too much, because in the grand scheme of things, it's only 4 more vertices, and that's going to be offloaded onto the GPU, so it should be okay. And right now we're not bound by the GPU, or we're not bound by either actually, because We're just waiting around. The game is spending so much time just idling. As we can see in the profiler. All this yellow is basically the game just waiting for the next frame. Still not sure why it dips down like that sometimes, but I never got a chance to test that. Yeah, but we can see right now it actually is faster to render twice than it is just to do the raycast. Because raycast, if I pause... Oh, well no, that's not technically true. So we have the render here, which takes 3%. And the raycasts actually only take 0.4% of the frame. And the render of the rest of the screen, that's interesting, is actually quite a bit faster than our shadow render. Maybe that's because this one doesn't have a screen shader, as the shadow render has to render everything to the red channel. Which is interesting because this is so simple. Lots of things to do, strategies to think through. But I guess the sprite shader is also really simple, so. Start the day out bright with some fruit delight, joy with every bite. Alright, so I think... Oh, and then the last part is we need to have a better way to mask light texture from one. Yeah, so basically we don't want any hard coded dimensions. And variable channel. So here, again, we need to get rid of these somehow. Especially because, well, this actually might go away because probably the mask texture will start to be the same size as the actual light texture. So that way we can just use the UVs of both. So that'll be a lot simpler. But we will need to somehow select what channel this light will take the data from. Which will really just change this value here. It'll go from mask red to green or whatever. Speaking about that, we should change this back to taking the actual light texture. I should probably change the light texture to not just be pure white. Let's see. That's strange. I must have changed the file structure at some point. Okay, so let's just, I don't know, change this to yellow. And the outside to light blue, just be a little different. And hopefully this should still work. So if I move the lantern around, yeah, it's still being masked correctly. Yeah, we can see the mask doesn't always work in the editor view. And I expect that's because the screen size is different in the editor. That's another reason why having those hard-coded values is not the best idea. Actually, so I wonder if I did this and then I scroll out. Yeah, we can see that scrolling out affects it. Okay, so let's see what. So yeah, it seems like we have a lot more to do with the shadow rendering actually. Also, this object here is just really messy. Probably should try to clean it up a little bit now that we have this really simple prototype. Okay, so let's we have about 15 minutes. I'm trying to see what would be the easiest. One thing we can start on now. Let's see, shadow mesh to one channel. I guess yeah, we can go ahead and do these maybe because they won't be because these three won't be affected by the shadow generation really. Okay, so this is basically comes afterwards. So first we need to be able to select what mask or what channel we'll render the shadow to. And then we need to render, and then we'll need to select like what size and position we'll render the mask to. And then we can try to render multiple lights. This will actually probably happen later on. Yeah, we should probably do this, probably this order, and then later on we can try and handle the shadow, because it's kind of separate. It's like basically these two separate groups of code are pretty much independent and they won't depend on each other. Okay, so let's see. So the problem here is we need to select what channel to render to. Select which channel to render, and then we need to not overwrite previously rendered data. I'm actually not sure how to do that. Let's create a new shader, and I'll pretty much just copy and paste this. So first I'll just do the select because it seems easier. Okay, so this will be, we'll pretty much just keep adding on to this new shader, but I'll keep this simple one because we know it works. Create shader, another unlit, and this will be I guess the shadow mask creator, and then we'll have a separate shadow mask applier. This is opaque, but do we want some of these other? I guess we will want to ignore projector. And then Z-Right, we actually probably won't need, well, Yeah, because we don't really care about the Z ordering for the shadow. And then this blending, I'd have to wait. This blending might actually be exactly what we need. Although it seems like it only does alpha. I'll have to look into this. For now, I'll just copy it over to remind me. Because that might be our key to not overwriting previous data on the texture. Okay, I don't need the fog again. Okay, so I think I can do something like this. Select, I think, color, forget the syntax for this. Unity, shader, color, property. Okay, so yeah, channel, select, just can't type, and color, and so we'll start with selecting the red channel. And so I think what we can do is something like this. Fixed for channel select, and then we can multiply these textures together. I guess I need to invert them. So I wonder if this will work. So 1 minus color times channel select. And even though in Unity or C# you can't, like, multiplying two vectors together doesn't make any sense. Well, I kind of like the way this works, but in C# you can't do this, but in the shaders, whenever you multiply two vectors, it does member-wise multiplication, which basically multiplies the x's, the y's, the z's, and the w's. Or in this case, it's red, green, blue, and alpha. Okay, so does that syntax work? Okay. So then on our shadow cutout, oh no, it's the shader that we actually give to the camera. Which is in here. And then I pass this. So will this work? No, it doesn't work. Alright, I'm gonna move the system around. So again, if I move the light around now, it will never mask out because our mask texture is completely white. So apparently the color is not working somehow. Reading some more. I guess I can bring it up. access color. I think this is how I did it. Access by using property name in square brackets. To do it in square brackets so nothing else is. It's gonna give me a syntax error. Yeah. Later on, in the shader's fixed function parts, property values can be accessed using the property name in square brackets. For example, you can make blending mode be driven by a material property by declaring two integer properties, and later on make blend command use them. Oh, I see. So, yeah, that's not talking about these, it's talking about like if you wanted to put a property here, you have to close it in square brackets. Like this is kind of like metadata about the shader itself. I think that's what it's talking about. Let's see. So let's try that. If I just return the channel select, I just want to see if it will show up red, which means that it's getting this default value of red. Okay, no. So is it just using, yeah, it's just using the camera as background, and it's not rendering. Oh, that's kind of interesting. The mask is working, but it's not rendering any shadow information at all. But I didn't change any of that code. All I did was insert this. So if I return 1 minus, oh, maybe it's because the alpha is 0, so it thinks not to actually put in any value there. Which would make the camera background here. Let's test that. Let's see. So I guess I can't really use any fancy code for this. Fixed for we'll want 1 minus color, or red times channel select red. And I want to do this for the other green and blue values, and then I'll just set 1 for the alpha. And I want to see if it's some issue with the alpha, and then the camera background. Oops, this should be green. Green here. Oh wait, red, green, okay, blue. The camera background is being a pain. I'm missing something. Oh, again, I was in Lua mode. Okay, so that was the issue. It's something, it has something to do with the camera. So I can't use this background because it overwrites values that have 0 alpha, which I guess makes sense. But yeah, technically, when we view this texture, the alpha should be empty everywhere because we're not writing anything there, but then when we move the light over it, it should still mask it out because the light only cares about the red value. So that means I need to, I guess, have some way to initialize this to all white, and then I'm gonna need to do a little code or a little research probably, because basically we're going to need to kind of write over this texture 4 times, and each time we'll deposit information about a specific channel. And I don't know, I've never had to do that before. I bet it might have something to do with this blend, but it seems like the blend depends on alpha. Let's see. So Unity, shader, blend. Okay, so we have turn off blend there, and configure enable blending. The generic color is multiplied by source factor. The color already on screen is multiplied by destination factor. And the same except different for alpha. This, yeah, so I think this is kind of the right track, except we basically want to be able to overwrite every value as we basically we want to save what's on the texture and then just overwrite one specific channel. So yeah, we might just need to play around with it a bit. But also, I guess we can't really test it until we get up 2 lights, so... But right now, I mean, we can't... It doesn't work at all because we need to somehow set it to white first of all. I guess it doesn't really matter if it's all white at first. Well, yeah, it does, because the shadow meshes will actually set it, or erase part of the texture. Or set it to black so that the mask won't show there. I guess if worst comes to worst, we can do 1 minus for the mask, but that seems kind of weird. That might be what we have to do, I don't know. It's like we could just have the actual color here, and then the mask we would do 1 minus red. Or yeah, 1 minus for the mask. Kind of did this, but I need to investigate blend modes. Oh, this one actually. But anyway, it's not time for me to stop. Yeah, so thanks everybody for coming by and watching and figuring out this puzzle with me. Hopefully tomorrow we'll make some more progress on this. If I don't really have any idea what to do, we might go back to the Tactical Lizard Tamer just for a while until I have time to research really well. But we'll see. But anyway, thanks everybody again for coming by. If you missed part of this stream or any previous stream and you want to catch up, you can check out my YouTube channel and my channel description, or !YouTube in chat, and I'll upload everything there. Also, I have a Discord channel if you want to chat with me and other viewers throughout the day. I'd really like to get a nice community going, so please feel free to take advantage of the invite. You can also find that in my channel or video description, as well as Discord and chat. And I'll be back tomorrow around 7:30 Eastern, and we'll continue either with this or back to Lizard Tamer. We'll just see how much I have time to research. I hope you all have a great night. Bye bye.